We've gotten to the point of the school year where the topics stop snowballing each other. And what I mean by that is it's been true throughout the majority of the school year that if you didn't understand something in Unit 3, you were going to really struggle in Unit 4 because you needed that Unit 3 stuff. Now we're going to start compartmentalizing into some different chemistry areas. You'll see that the unit that we're starting now, or that we kind of started yesterday with the water video, it's the liquids unit. All right, and next unit is going to be or 2 units from now actually, that they switch some stuff around. But we've got a gas unit coming up where we're just focusing on some different specialized areas of chemistry that are all chemistry but aren't directly connected to each other. You've already learned about liquids during our first unit of the year when we studied matter. We did phases. You know what a liquid is. All right, it's got a volume that's constant but a shape that's not. I can make a single volume of liquid take up different shapes depending on what container I put it in. We know that their molecules kind of flow over one another, which is what gives them the ability to change shape. But what we're going to do is take a deeper look into liquids, and really one of the most interesting things about liquids is their ability to dissolve particles. And when you start looking at how they can dissolve particles, there's a lot of different chemistry going on. We call these solutions. A solution is going to be a liquid that's got evenly dissolved particles throughout it, and there's a lot of vocab that comes along with that. So take a look at your new cheat sheet, and let's look at some solution chemistry. So here's a liquid. All right, it's nothing too interesting. It's just water. Whenever you have a solution being created, again, meaning that we're going to take this liquid and dissolve particles in it, the liquid part is the solvent. So we're going to call the solvent the item that does the dissolving. So there's your first vocab word. Now the solvent doesn't have to be water. It just usually is. Water is called the universal solvent, and I'll elaborate more on that before I finish today. But whatever you have more of is usually the solvent. So in a moment, I'm going to show you the other item that we're going to dissolve in the water. But the item that does the dissolving is the solvent. But you have to have the other guy too. You've got to have the item that you're going to dissolve in the liquid to create the solution. All right? So we call him the solute. The solute is the item being dissolved. So I've got my solvent, all right, the item that's going to do the dissolving. I have my solute, the item that we're going to dissolve. It's just some crystals here. So if I mix the two together, whoops. All right, got them mixed together now, and give it some stirrage. It's not a word, don't say stirrage. I'll create a solution. So the solution is the mixture of the two. When the solute is dissolved in the solvent, you'll have the solution. Of course, your cheat sheet has all these vocab words for you right up top as the basis for this unit. You'll notice that on your cheat sheet it uses the phrase homogeneous. That's a word we haven't seen since September. But a homogeneous mixture is one that when you mix the parts together, you can't see the parts. So what you'll see here is that my sample looks like one continuous uniform thing. All right, you can't see the crystals, you can't see that blue part, you can't see the water. It all looks the same. Because when we dissolve my solute in my solvent to make my solution, it's all going to be in equal parts. If I poured all of y'all a sample of this solution, it would be the same for each of you. Now, there's a bunch of different aspects to making this solution that scientists care about. For example, I just put a little bit of that solute into my solvent, but what if I had a lot? What if I needed to dissolve a bunch of particles? For example, it's a sugar cube, all right? Nothing too crazy, just a sugar cube. But if I wanted my sugar cube to be my solute, the item I was going to dissolve, and I was going to add it to this solvent here, how could I make it dissolve faster? What could I do to speed up the rate at which it would dissolve? One of the things that I could do is increase the surface area. Now what that means is I would want as much of this sugar touching the liquid, the solvent, as quickly as possible. The problem with the sugar cube is that there's sugar trapped in the middle. What could I do to increase its surface area? What is that? Break it down. If I can take my sugar cube and I turn it into dandruff, that's gross, and I turn it into granulated sugar, if I add that to my solvent, then it's going to dissolve much faster than it would have had I put the cube in there. So one of the ways to increase the rate at which a solute will dissolve is to increase the surface area, or an easier way to understand that, break it into smaller pieces. Well, I don't know if you can see, but the sugar's still there. All right, it hasn't dissolved yet, which means it hasn't gone into solution. I can see my solute still sitting in my solvent. So what's another thing I could do to make it start dissolving faster? Stir it. All right. We've got a big fancy word called agitate is the good science word for it. But what you're doing is you're adding kinetic energy, which is energy in motion. And by adding that energy to the solute and solvent that we're trying to get mixed together, it's going to help increase the rate at which it will dissolve. I still see a little bit, though. There's still a little bit of solute undissolved. There's one more way I could speed it up. What is it? We could heat it up. All right? Again, heat is energy. So it would be adding more kinetic energy. If I put this on a stovetop, all right, and heat it up and boiled it away, it would increase the rate at which any solute would dissolve in the solvent. Any of y'all like Lubies? Any Lubies fans in here? Let the old people treat you to some lunch. It's good stuff. I like those old people. They're chemists. Those people. They're chemists at the end. It's not true at all Lubies, because there's always people who say, I've never seen that before. But if you go to the Lubies at Bitters, they have it set up in a very scientific way. But you don't like the sugar? They have the very end of their line set up in a very scientific way if you're getting tea. The way the tea station is set up is they have the tea pre-poured for you just in glasses, but it's poured only 2/3 of the way full. And then they have the sugar station right next to right after those pre-filled glasses. And then they have the ice right afterwards. Why is that brilliant? Because what? Because you can make your own tea, which would be true no matter what order they put those items in. But listen again. They have the pre-filled cups, followed by the sugar, followed by the ice machine. Why is that brilliant? Because the tea's still hot. What they give you the opportunity to do is take your tea, put the sugar in it, get it mixed nice and beautiful and evenly, and then add the ice to it. And your sugar. If you add too much, it's just sugar water. But your tea will be perfect. Versus most restaurants where they bring you a thing of unsweetened iced tea and the sugar package is just sitting on the table. when you pour those sugar packets in, they sit on top of your ice, and you have to really work at it to mix it up. So anyway, kudos to Lubies. The next two vocab words are ones that you'll struggle with on the test for some reason. And it's just vocab, so I don't really understand why. But it's diluted versus concentrated. Let me show you an example. These two items can be present in different amounts. You can have a solution that's got a lot more solute than it does solvent, so there's a lot of stuff dissolved in it, but not a lot of water. Or you can have the opposite. You could have where there's a bunch of solvent, you've got a ton of water, and just a little bit of stuff dissolved in it. If you have more solvent, then that is going to be a diluted solution. If you have more solute, then that's going to be a concentrated solution. And the part where you get confused is I'll give you a situation and your brain doesn't not so much understand the difference between diluted and concentrated, but you might have an issue figuring out what the solute and solvent is. Your online assignment will give you practice. But let me show you an example of what I'm talking about here. All right, we've got a beaker here that the AP teacher peed in for me. Yeah, I'm just kidding. All right, yeah, it's a colored liquid. But anyhow, this is very concentrated. This is a very concentrated sample, and here's why. I put just a little bit of water in here. There's just a little bit of water, but then I dumped chemical into it. All right, I dissolved a bunch of particle into it to make it this dark gold yellow color. So it's concentrated because there's more dissolved stuff than there is solvent that it's dissolved in. But I could dilute it if I wanted to. How would I dilute it? What would I do to dilute this? Add more solvent. If I can make the solvent become more, it would be diluted. So here's what I'm going to do. I have an empty beaker here, so I'm just going to transport this into the empty beaker. All right, haven't done anything. So it's the same sample, still has that real dark, beautiful gold color. And now I just have water. All right, so very concentrated because there's a lot of solute and not a lot of solvent. But let's dilute it. Turn this around before I get soaked. All right, as I dilute it, you'll see that color goes away. Still yellow tinted, but by no means as beautiful as it was a moment ago, because now there's so much solvent. It's a diluted solution. There's more solvent than there is solute. How could I concentrate it again? Add more of the stuff that made it yellow. Add more of the solute. Or I could dilute it even more. What would happen if I added 6 more of these? I mean, bigger container. But if I added 6 more things of water to it, what do you think would happen? It would turn clear. Eventually, it'd just go white because it would be so diluted because I added so much water to it. It'll take some practice to get this idea straight, but you need to know that vocab. The last topic I want to cover today is the topic the video covered yesterday, but there's some stuff that we want to be on the same page on as far as water goes. Obviously, water is very important to us. Without water, you're dead. But as far as solutions go and liquids, it's number one, so we definitely study it in chemistry. I said a moment ago that water is usually the solvent that's used in a solution. And the reason is because it's the universal solvent. Here's how it works. We have this saying in chemistry that like dissolves like. And what that means is if I made a chart of solutes and solvents, if I have a positive solute, then it will dissolve in a positive solvent. Like dissolves like. So, if I have a negative solute, what type of solvent will dissolve it? A negative solvent. Here's the thing about water. Water looks like this. All right, it's H2O. It looks like a Mickey Mouse. It's what we call polar, and that's a real important word. The fact that water is polar. This refers to the fact that water has both a positive and a negative region. All right, these hydrogen areas are positive, and this oxygen area is negative. So if water is my solvent, what type of particle can we dissolve? Anything that can be dissolved. For the most part, will dissolve in water, because water's not positive or negative. Water's both. We call him the universal solvent because of his polarity. Some other cool attributes of water that you're probably aware of but are important to mention as far as assessments go. Water's surface tension is amazing. You saw in the video yesterday and the one 2 days ago actually, the ability of animals to run across the top of water. This is because where water changes mediums, meaning where it goes from like being a body of water to air, that surface that exists there, the strength there is enormous. It's the reason why you don't belly flop off a diving board, because when you strike that water, the surface can feel like concrete. They did a study on Mythbusters once upon a time, where they examined what happens if you, well, first off, you know what happens if you jump off the Golden Gate Bridge? You die, all right? It's just into water. I mean, it's just like diving into water, right? But from that distance, that water, that surface is so strong that when you strike it, it breaks your body into 7,000 pieces, and then you enter the water and get to swim. So Mythbusters did this thing, and they're like, well, what if the surface tension was broken before the item hit the water? What if you jumped off the bridge holding a cinder block, but right before you strike the water, you let go of the cinder block, it hits the water, breaks the surface tension, and then you could just go in and survive. And it turns out that you still die. So, don't jump off any bridges. Some more vocab, and I'm going off your cheat sheet. Hopefully you're reading along with me. Cohesion and adhesion. Water is cohesive, meaning that water loves water. Water likes to stick to water. It's the reason why when you turn on a water hose or whatever, the water doesn't just go crazy. It comes out in a nice stream because the water molecules are actually holding hands with one another. This is really important in things like plants, because once a plant can get one molecule of water attached to its roots or attached to the xylem where it's going to go up the plant, then it'll pull all the water up together because all the water molecules stick to one another through cohesion. They're also adhesive. All right, cohesion means water sticks to water. Adhesion means water sticks to everything else too. All right. Whenever you do get out of the shower, for those of y'all that shower, you'll notice that you probably have to dry off because the water molecules don't just hit you and fall off of you. All right, they certainly don't. They certainly have the ability to fall off of you since you're waterproof, but they stick all over you because water is adhesive. These are a couple things that you know about water. It's kind of like a duh thing, but make sure that you know the vocab words attached to them. Finally, and here's the most impressive thing of water that you'll hear all day. Water is one of the only compounds on the planet that is more dense as a liquid than it is as a solid. If you take a solid form of anything and put it in liquid form of the same thing, it will sink. Like if I have a coin, do I have a coin? All right. If I took this quarter, all right, and then I had a thing full of melted silver, all right, and I dropped the quarter into the silver, the quarter is going to go to the bottom. And that's true for just about anything. If you put the solid version of something in the liquid form of the same substance, it will always sink, except water. Because what happens when you put solid water in liquid water? Which is, for those of y'all that didn't follow that, what happens when you put ice in water? It floats, all right? And this doesn't strike you. You've experienced this for 15 years, so it doesn't strike you as weird. But if you take that and compare it to all the other substances on the planet, nothing else does that. And it's actually really good for several different reasons that water behaves this way. The most notable one is in regard to seasons changing and outdoor bodies of water that freeze over. The fact that they freeze over is really important to ecosystems that live in that water. Because if lakes were made of anything but water, any other liquid that all those animals and plants were living in, it wouldn't freeze from the bottom down. It would freeze the other direction because the ice would start on the bottom. The solid version would start on the bottom, freeze on the bottom, the whole thing would freeze and everything would die. But it doesn't do that because water is unique. That top layer freezes, and once that top layer freezes, it actually insulates all the water beneath, and none of the other water gets cold enough to freeze, and the fish give fins up for that because they don't have thumbs. They're fish. Any questions on solutions?